This is part 2 of lesson 4.6. We had just finished off looking at question D in part 1 of the video. So what we did is we looked for a greatest common factor because we had 4 terms or more. So we're trying to take out a greatest common factor first just to make things a little bit easier. And we found that we could take out a y from all the terms, and so you divide each term by y, and we end up with x5 plus x squared y squared minus x cubed y squared, and then minus y4. And then we can look to see if we can group things together that might have some commonalities. It looks like the way we have them organized here might actually work out quite well. If you notice here, we have some commonalities between the x5 plus y2 y squared. So we can actually treat that as a group of its own, and then same thing over here. We have this group over here. We can treat that as a group of its own as well. So what I'm going to do is I'm going to put this into even larger brackets or square brackets here, and start pulling some factors out. So let me just erase this little bracket here. Start pulling some factors out of the common groups that we have here. So from here, let's say I can take out an x squared. If I take out an x squared, that gives me x squared brackets. So x to the power of 5 divided by x squared is x cubed. Remember, just as an aside here, x5 over x squared, you're subtracting your exponents, right? So it's important that you review those exponent rules. Otherwise, you're going to be lost in this situation here. So 5 minus 2 is x cubed. And then over here, we're taking out our x squared in its entirety. So just to show you for the sake of completion here, x squared y squared divided by x squared. You're basically doing x2 divided by x2 here, so that's x0, which is 1. Basically, these are canceling out. And so what we have left is plus y squared here. And let's see what we can take out from the next one here. So it looks like we can take out, we can't take out an x, definitely not, because this term here doesn't have x. But we can take out, so we can take out a y, a negative y squared from here. So they both have y's, and then y squared is the most you can take out. So let's take out negative y squared, brackets. If we take out negative y squared, that's going to be, so negative x cubed y squared divided by negative y squared is simply x cubed. And then negative y4 divided by negative y squared is plus y squared. Now, I went over that quickly, but what you should do is reason that. If you don't get y, negative y to the power of 4 divided by negative y squared is plus y squared, write it out to the side to see what I'm talking about, to make it more visual for yourself. You need to start doing that. Because I could explain every little step to you, but until you go back and review the steps, review the rules, it really won't make sense ever for you. So become that strong independent learner and review those rules. And then I'm going to put the bracket around here. And now you'll notice we created something beautiful here. We have x cubed plus y squared, x cubed plus y squared. That's a common factor between the x squared and the y squared term. So we're going to go here, and we're going to write y. We're going to open up some brackets here. We're taking out the x cubed plus y squared. And then we're going to open up some brackets for the leftovers, just like we did in previous videos. X squared minus y squared are left over. Now we're almost done. Before you really call it quits, let's take a look at something else you created. If you look carefully here, you have two terms here. And it looks like they are perfect squares. The first term here is a perfect square, second term here is a perfect square. And then we have a minus here. So it looks like we have a difference of squares that we can factor as well. So if we do that, we get y. X cubed plus y squared, you can't really factor that anymore. There's nothing to pull out of there. It's two terms that there's a plus, so we can't factor that, as we've seen in the previous video. This one here is a difference of squares, so we'll open up two brackets. Square root of the first term is x. Square root of the second term is y. And since it's a difference of squares, one of the brackets gets plus, one of the brackets gets minus. So if you didn't quite see what I did there, make sure you review the difference of squares method. Don't stop right away when you think you have everything factored. If you do, then you might miss out this important piece, out on this important piece here, which is that it's a difference of squares. So what you notice is that the more practice you do, the more you can spot this. It's really the only way around it. When people do this and they make it look easy, they didn't get it right away. It took them a lot of practice to do. So that's why I'm saying this section, this chapter, does require you to practice. There's not many skills to learn, but there's many skills the skills that there are there require practice to master them and to become good at using them. So we did some examples of factoring, applying the different tips that we saw up here in the first video and in this video here. Now we're going to go and move on to some word problems to see how they connect to this factoring here. So let's start with word problem number 2 over here, example number 2. The area of a rectangle is given by the relation a is equal to 8x squared plus 18x plus 7. Determine expressions for the possible dimensions of this rectangle. So first of all, I want you to get that we have our area written out. The area is 8x squared plus 18x plus 7. And this is the area for a rectangle. A rectangle. There's a poorly drawn rectangle. You would draw a better one with a ruler. And you know that if you want to find the area of a rectangle, basically the surface area here, you would do its length times its width. So length times width. So area is equal to length times width. And so since you have this standard form, what I'd recommend you do is you try to factor it. You try to factor it. When you factor it, you'll see something interesting that'll happen, and you'll make that connection. So let's go ahead and start factoring. Can we take out a greatest common factor from here? It doesn't look like it, because it had 8 and that 7, that's tough to do. So what I'm going to have to do is I'm going to have to, this is more of a complex trinomial here, I'm going to have to find the product, two numbers where the product is equal to a times c, so to 56, and the sum is equal to 18. So I know that 14 times 4 gives me 56, and 14 plus 4 gives me 18. So those are my two numbers. That works out just fine. So remember, when you do that, we're using decomposition now. So we're going to have 8, or area is equal to 8x squared. We're decomposing the middle term into the two numbers we have there. So we'll do plus 4x plus 14x. That's still 18x, just broken up or decomposed into those two numbers, plus 7. Now I've created two groups from which I can factor some commonalities out of. So I'll have a area is equal to, from this group here, I can take out, let's say I can take out 4x. And if I take out a 4x, 8x squared divided by 4x is 2x. And then 4x divided by 4x is 1, so plus 1. And from this group here, let's say I can take out a 7. So 14x divided by 7 is 2x. And then 7 divided by 7 is 1, so plus 1. And now I have this in common with the 14 and the 7. And so I can just pull that out and have my two brackets left over. So I have 2x plus 1. And I'll multiply that by whatever's left over, so we have our 4x plus 7. And so what you'll notice is that we have an expression, an area expression. We have something times something, length times width. So these two terms here could very well represent the length and the width of the rectangle, right? So area is equal to length times width. Therefore, based on our factoring, our length is going to be 2x plus 1, and our width is going to be 4x plus 7. So what we just did here is we determined the factored form from the standard form. The reason we did that is because we knew that the area of the rectangle is length times width. So this way we got two different terms. We have our length over here and our width over here. So this is one dimension. This is the other dimension of our rectangle. So let's move on to question B over here. Determine the dimensions and area of this rectangle if x is equal to 3. So what we've done is we've specified a value of x. At this point, we just had x in our length and our width, but now we've specified a value of x, and we can actually go find what the length and width are, and then we can use it to find the area of the rectangle. So let's go do that. Keep it nice and organized. So we know, let's remember that our length is 2x plus 1. And we can go and replace the x by 3. So we have 2 times 3 plus 1 gives you 6 plus 1. And we'll write 7 units. We don't know what the units are, so in this case we'll just write 7 units. Let's do the same thing for our width. Width is equal to 4x plus 7. We'll go and replace the x by 3, so 4 times 3 plus 7 gives you 12 plus 7, which is 19. Don't forget to write units down. We don't know what they are, so we'll just write units. They could be centimeters, they could be meters. And then we'll go and find our area. Remember that area, the formula is length times width. So that means that our area is going to be 7 units times 19 units. And if you do that in your head or put it in your calculator, you'll get that you have 133 units. And since it's area, we know it's squared. So this question relied on your knowledge of the standard form, factoring a standard form to get its factored form, and knowing that the area of a rectangle is length times width. The more you know from previous experiences and previous sets of homework and just prior knowledge, the easier these problems are. If you don't have a lot of that prior knowledge, it is a bit more difficult, but you can develop it. You can go back and review it, and that's the beauty of math. You just have to go back and review stuff, and it becomes a little bit easier for you to actually grasp once you do it. That's really the only barrier. Everyone has the ability to do this type of math here. So let's take a look at our next question. We won't have time to finish it in this video, but at least we'll get started. So question 3, the area of a circle is given by the relation a is equal to pi x squared plus 10 pi x plus 25 pi. And we want to find an expression for the radius of the circle. So I'm just going to give you a reminder. We have area of a circle here. Remember that the area of a circle is pi r squared. You have a standard form given to you. So when you have a standard form given to you, even if you're not really sure what to do, write out the area formula and then try to factor just to see if anything kind of connects. You might connect the dots once you have that factored form.